Hello guys, welcome to East Coding. In this video, we are going to see the Leetcode problem number 1544. Make the string great. Let's get into the question. So the problem statement is, we are given a string S of lowercase and uppercase English letters. A good string is a string which does not have any two adjacent characters such that current index, which is I, and the current index plus one, both the characters such are in such a way that current index character current index and the character next index are same letter but in uppercase or vice versa. So uppercase and lowercase. So if the current character and the next character is uppercase lowercase combination or lowercase uppercase combination, it is considered to be a bad string. So we should not have such combination. To make the string good, we can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. So after this, return the string after making the string good, and the answer is guaranteed to be unique under the given constraint. So notice that empty string is also a good string. So without further ado, we'll go into approaching the problem. So the first step for any solving any problem is to define the problem. So the input is a string and output is a good string. And str. So the what is a good string? Good string is a string without any bad sequences. Good string, a string is called str without bad sequence. So bad sequence is nothing but sequence of length 2 and characters, that is the this is the, let's consider this as a sequence. The first character will be lowercase and next will be uppercase. This combination is a one type of bad sequence. Other combination is upper and lower, and both the characters are same. For example, a cap lowercase a, uppercase a, and uppercase a and lowercase a. These sequences, this is an example of bad sequence. So we need to eliminate the given bad sequences present in the given string and return the good string. So that's all about the problem, and they have given that it is guaranteed that given input will be only characters, that is English alphabets, uppercase and lowercase. So any other edge cases we need to deal with. So we have any other edge case. So yeah, there is no other edge cases, and they have mentioned that empty string also a good string. So that's all. Now let's approach find the approach for this problem. So second step, which is approach. So the approach for this problem, so how can I approach this problem? So two letters of same two indexes having same letter with different cases are considered to be bad sequence, right? So how can we remove those? So we'll keep a string builder. So let's consider this case. Let's say A, B, C, capital B, and A and D. This is E. So consider the string. What will be happening? So when we are current character, we need to check the previous. So for each character we are meeting, we need to check what is the previous character. So for each character we will be checking what is the previous character. So if previous character is the opposite case with same letter, we'll remove the current character and also the previous character. So I will be doing the process continuously. So when we consider this test case, you can see that we will firstly come to E. If you move to EA, then move to B, we'll check previous, it is A, so we'll continue. We'll check the previous, it is B, so we'll continue. We'll check previous, it is C, and it is lowercase, so we'll remove both the characters. And now we'll move to B, so we'll check previous, so we have eliminated both these, so we'll check with a previous character, and it is same letter with a different case, so we'll eliminate both the characters and we'll move to next index. We'll check for the previous index. Since we have eliminated 4, we'll check with the index 8, that is 1, first index. So it is same letter with different case, so we'll remove both. We'll move to D, next character, and we'll check with the previous character. It is not matching, so we'll continue. The string has ended, so finally after removing the elements, that is characters, we get answer as ED. So this is the answer. So how are we going to approach this? So each time we not only need the previous character, that is previous index, but the previous character actually we need. So for each time we need the previous character that we have included in our answer. So when we reach here, we check for previous character which are included. So answer is C. When we reach here, we check for previous character included. So B was previously included. So how can I keep track of previous what to say previous results? So how can we store the previous results and compare with the current index? So if so, when you are removing the top of the previous result, we need the other results too. Not only result but results. So we need to keep track of every previous results and compare them with the current. So in this case, we can clearly see that we can use a stack. Stack has a property of LIFO, which we can use to find the previous characters that we have included. So approach we are going to use is keep on add characters to stack. Let's call it as st. And if previous character is same letter and different frequency, sorry, different case, we'll remove or else we'll add. So this is considered the second step, this is first step. So if this is the case, we'll remove the top character and we'll continue, or else we'll move to here. So that's all about this approach. So let's get into the coding section. And the time complexity of this approach is we go of n, and the space complexity we go of n. So let's get into the coding section. So initially we'll have a stack of characters, call this as st. So we'll call this as q, sorry, included characters. That's new stack. So write it over the complete array, complete string. So using the high index, and while the stack is not empty, and stack's Greek value is, so we need to check the peak value, right? So we'll have a helper function is bad of previous character, which will be included as dot peak, and current character. Current character will be, so let's have this as ch. So we'll pass the current character. If this is the case, we'll so we need we'll just pop the peak element. So we don't need while loop, since we are just going to check for one instance. So we'll write the helper function later. So if this is the case, we'll remove, so pop, or else we'll add the current character to the included characters. So finally we'll form the string using the included characters. How can we include that? We'll be appending each character to the first index. So well, this is not st, this is included characters. Each time we'll append to the first. So I think the method is include method pop. We'll pop and insert every element to the first position. This is 0th index, and finally we'll return the string representation of the string builder. So why we are using a string builder? Because string is immutable. In order to construct a string, we'll be using a string builder. So we'll write the helper function, just boolean is bad with character A and character B, and we'll check. We'll have a you can check easily the condition by using. So we'll, before writing this, we need to know about the ASCII values. So ASCII values, this is the ASCII value table. So you can see the ASCII value of capital A is 65 and ASCII value of small a is 97. So we'll find the difference between them. So 97 minus 65. So it is 32. So we'll check whether method absolute value of a minus b equal to 32. So yeah, so we'll check this. Included oh sorry, it's a function. So we'll check this. So we'll submit it up. Accepted. So that's all about this video, guys. Thanks for watching this. Have a great time.